Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 6 of the lesson on reciprocal trig functions, and it's one more example to take you through. Okay, so here we have solve the equation cosec theta equals 2 sine theta, and this is in radians between 0 and 2 pi. So check your calculators in radians mode before you do anything else. Okay, this one's a little bit different because we've got two trig functions here. I'm still going to be using the fact that cosec is the reciprocal of sine, but because I've got sine theta here as well, I'm actually this time going to write that cosec theta is 1 over sine theta, and that equals 2 sine theta. So now I've got everything in terms of sine theta. You might see how this is going to be manipulated. If I multiply both sides of the equation by sine theta, I would have 1 equals 2 sine squared theta. And I'm just going to write that the other way around now. I'm just going to write that 2 sine squared theta equals 1. And what that means is that sine squared theta will equal a half. Now remember, just like the previous video, sine squared theta, that's the same as having sine theta squared. So I'm going to square root both sides to get sine theta, but I must remember that it's plus or minus, and the square root of a half, 1 over root 2, but your calculator will write that as root 2 over 2. So just as before, I'm going to have two sets of solutions here. Sine theta equals positive root 2 over 2, and sine theta equals negative root 2 over 2. 4 solutions in total, 2 from here, 2 from here. So, sine inverse of root 2 over 2, which is 45 degrees. Pop that onto a caster, except we're in radians, so it's pi over 4. Pop that onto a cast diagram, so 0, pi over 2, pi, 3 pi over 2, and 2 pi, A, S, T, C, and pi over 4 quarter pi is going to go in here, and that is the angle with the horizontal. Now, the value of sine theta is positive, which means I want the two quadrants where sine is positive, which is A and S, not T, not C. So my second line goes in here in the sine quadrant, and this angle with the horizontal is pi over 4. Measuring around anti-clockwise from 0, I want this angle here, which means I'm going to do, now remember it's not 180, it's pi, so I'm going to do pi minus pi over 4, which gives me 3 pi over 4 as my second solution for this set of solutions here. So what I have here is theta equals pi over 4 and 3 pi over 4. And that's my first two answers for when sine theta equals root 2 over 2. Next one I'm going to do is sine inverse of negative root 2 over 2. And that actually comes out as negative pi over 4. So, draw that out in your cast diagram. This is the first negative one we've met, so I'll just take a bit of time over this, draw the cast diagram quickly. It's A, it's S, it's T, C. Now negative pi over 4. Pi over 4 went up here. Negative pi over 4, it's the same angle, but because it's negative, instead of going anti-clockwise around the cast diagram, we're going to go clockwise into this quadrant here. But notice that I'm still labelling it as pi over 4, because that's still the size of the angle. Now, sine theta is negative, so we want the two quadrants where sine is negative, which is T and C, not A and not S, which means that my second line is going to be drawn in the tan quadrant here, with this angle here being pi over 4. However, because my limits are between 0 and 2 pi. I'm still starting on 0 and measuring anti-clockwise round. So that one there, I've gone all the way around to pi, plus another pi over 4. So pi plus pi over 4, which is 5 pi over 4. And then again, starting back on 0, going anti-clockwise all the way around to this one here. That's the full circle, the full 360. Of course it's 2 pi. Take away pi over 4, which is 7 pi over 4. So these are my two solutions for theta, 5 pi over 4 and 7 pi over 4. Coming from this one here. Okay. So 4 solutions in total, 2 from the positive root of a half sine theta equals root 2 over 2, 2 from the negative root sine theta equals negative root 2 over 2. So 4 solutions in total between 0 and 2 pi. And pi over 4, 3 pi over 4, 5 pi over 4 and 7 pi over 4. And if you've made it all the way through all 6 videos, fair play to you, because if you're like me, you'll be absolutely exhausted. Great job.